In this third part of the demonstration, we're going to look at a full whole data set. For the purposes of this demonstration, I'm just going to load a partial whole I've already prepared. What this load does is it searches through the directory for processed objects created by CoreSpecViewer. It will then check to see if they all have the same borehole ID, and then it will sequentially load them whilst aggregating metadata such as box number, from and to depth. So as you can see, this is 8 boxes from a hole drilled by Geological Survey Ireland in County Roscommon from the Hill Street hole. We have 8 boxes loaded with a depth range of 233.3 metres to 266.9 metres. These boxes have all been processed using CoreSpecViewer, and you can see that a number of products have already been calculated, as well as the base data, crop, mask, SAVGOL, CR, and the segmentation data. We've also calculated the 2320 nanometer feature for each box, and we've produced a Pearson mineral map for each box. So if you look at the mineral maps, this will show you the what's available, and if you look at the feature position, you can see variations there. So while this does allow you to look at box by box information, it also allows you to generate downhole features. So in the base data for the downhole, we can see we have a spectral profile and we have a pixel per depth dataset. When you click generate base datasets, this will, using the unwrapping statistics, create a one-dimensional profile down the hole where each pixel is the average of the core width of that hole. Of that depth. You can change it to the median instead of the average if your data prefers that. So I've already calculated the downhole base datasets. These are persisted to disk and are associated with the whole object on open. We can also aggregate our mineral map datasets into a downhole profile. Here we'll use the mineral map in range collection, and this will now iterate through each of the boxes, calculating a downhole dataset. It produces a fractions and a dominant mineral display. So if we look at the fractions, this is the proportion of each mineral across the full row width. So as you can see, the upper part of the hole is unclassified, so the mineral map was unable to assign a mineral, but it's dominated by this light blue calcite with some thin dolomitic horizons and some clay horizons with some chlorite horizons as well. As you go downhole, dolomite becomes the dominant mineral. If we were to look at the aggregation of the feature dataset, we can use the box level data to generate a 1D profile of the features. We have to do depth and position separately, but let's have a look at the position. And we can display that. So as you can see, unsurprisingly, the 2320 feature alternates between calcite and dolomite in the top part of the hole, between the longer wavelength to the shorter wavelength, and then as you get further down the hole, it just becomes dominantly shorter wavelength, more dolomitic. We can, using the full hole dataset, calculate k-means for the full hole on the profile. Again, we'll do 5 clusters and 50 iterations. And we can then display the k-means clusters image. And you can see class 4 is most likely related to the dolomite class with some variation above that. We can also run our bandmath operations on the full hole profile. So let's have a look at the R2300, and we'll call this R2300 bandmaths. And we'll run it on normalized spectra just to show that that's an option. And that will appear in the downhole datasets. Again, very similar to what we see in the feature extraction, although a bit noisier. We can also extract the feature from the profile directly without aggregating the whole level dataset, the box by box level dataset. And you can see in this dataset we have the 2320 nanometer feature, but we also have the profile derived 2320 nanometer feature, and they are very similar, which is again unsurprising. What's useful about this is you can currently set the resampling window. So by default this resamples to 1 centimeter intervals downhole, and in this length of hole, 30 meters, that you are seeing reasonable results. But if you are working with much greater hole depths or much shallower hole depths, you might want to adjust that. So let me set the resampling window to 1 meter and show the fractions again. You can see this is much coarser resolution, and we could set it to 10 centimeters. And show again, and you can see it's between the two. This is not the best way to display it, but if you are working on a larger hole, that could be very useful. So I think this is one of the more powerful facets of CoreSpecViewer. This final section is just to demonstrate how far you can push the CoreSpecViewer software. Here I have loaded 234 boxes of memory mapped data sets from a 1 kilometer hole drilled by Geological Survey Ireland. You can see the depth range is from 80 centimeters to 1001 meters. You can see that the UI remains responsive while this data is loaded as you view through the false color images of all of the boxes, and you can see the products I've derived from it. If we have a look at the mineral map using a collection I produced, it does take a few seconds to load, but you can see there's the mineral map products for all of it. And I've used this mineral map to calculate downhole products, and you can see this is the fractions. Again, you have calcite and dolomite dominating, obviously. This plot here is at the 10 centimeter sampling interval, and this plot here is at the 1 meter sampling interval. So you can see the value in being able to modify the resampling window. And here on the right we have a profile derived data set of the 2320 nanometer feature. So this just shows the capacity for handling large volumes of data that this software was built to be able to view, interpret and consider all in one place. So that's it for this demonstration. If you're watching this video a long time after I released it, it's possible that there'll be many new features added. This software is still under active development. As I mentioned, it is open source and it will remain so under the GPL 3 license.